Metal Powder Works is an early stage company that's just emerging from the quiet. We've invented a fundamentally new process for making metal powders. And the goal that we had from the very beginning was a high efficiency, high yield in terms of size, such that most of the product would be made to the specification.
About 95% of the powder you make is the right size to print. Other powder making processes, only about 20 or 30% of the powder is the right size. So by having a higher yield, as it's called, more powder that's usable, you actually have a lot less waste in the process.
The element of solar car, it's all about energy efficiency. So the trick is to have a car that's as light as possible, but also a car that is very aerodynamic. So if you can get those two things correct and have a reliable car that will finish the race, that really greatly improves your chances of success. I was talking to a friend of mine, Katerina, who knows John from MPW, and I was talking to her about the solar cars, and we thought that maybe Katerina knew John, and that perhaps this new 3D printing with metal might help us in some of our components to reduce the weight of our car. This particular piece that we're replacing was quite heavy and quite over-engineered for what we really needed. So as we progressed through this and trying to reduce weights, it's always something we wanted to take some weight out of. And we just saw this new process as an opportunity to take that weight out.
Metal Powder Works has the ability to make this really interesting, low-cost powder from bar feedstock. But really we had never known whether or not we could actually functionalize that type of powder. It's definitely something new in the industry right now. It's not a conventional way of making metal powder for additive manufacturing.
The challenge for us was solved relatively early in partnership with HRL, where we demonstrated some tensile properties which showed very high strength. So that allowed us to prove to the Team Aero group that we could hold positive margins on the parts, so that it was safe and met the form, fit, and function.
HRL's position was mostly just to make sure that they got the quality powder that they needed in a timely manner. And so we processed the powder internally. We added our functionalization agents in order to make it printable. We did some initial development work on just proof of concept, making sure that we could get material properties that were equivalent to rot. After demonstrating that, it was then passing the system and material over to Beehive to do the full parameter development and component fabrication.
We used a generative design tool so it would closely follow the load path of the part itself in service. And we came up with this very nature-inspired design, which could be printed. We then worked with Beehive to ensure that the printability was there so that we weren't sacrificing weight for unnecessary cost.
So we took a little bit of time to play with the powder. Surprisingly, it was kind of we'll call it a one-for-one fit, but did not require a ton of work to take it from where we were to where we needed to be to produce these parts. Once we got through that stage, it was just printing parts. They were well designed for additive, so just put it on the plate and hit go.
It went quite smoothly. Once Beehive identified a print window for it and printed the parts, we were then able to send it to heat treatment, hot isostatic pressing, machining, radiographic inspection, all of this, and everybody was able to keep within their schedules. And literally, I've never seen the part and never had to touch it. It worked that smoothly.
It's opened our eyes to what's kind of possible in both the powder morphology and powder production standpoint, and where we can think about leveraging that for our customers in the future is to make sure that they have low-cost available material systems, and this is a really good demonstration of being able to do that.
One of the things that Metal Powder Works wished to get out of this project was to show that our powder, while it doesn't look like atomized powder, it functions, behaves, and acts the same, if not better, in terms of part performance.
Very surprised by the behavior of the powder. We thought, without being spherical, it might have some flowability issues, but we didn't run into anything like that. Got nice dense parts, pretty easy to develop parameters for, so all in all, we're very impressed with that powder. I think that'll lead us to looking at it in the future as well.
from a processing perspective, this is a totally new powder. It's a new way to process material systems. And we think it has a huge potential for enabling lower cost, more distributed additive manufacturing.
MPW and the other partners have helped to design these fantastic new suspension mounts for us. And it has it's cut a good chunk of weight out of the car, and it also just looks amazing. And it's this amazing new technology that it can show off to other solar car teams as to what the future of how we can manufacture these components.